So, hello everyone, welcome back to another video. So, in this video, I'm going to tell you about if a number is given with the alphabet A, suppose if it is given 3, and if you have to convert the given number, like, and another number is given basically in a question with the letter B. Now, B can be any number. Let's generalize it with the fact like A is given the value X and B is given the value Y. Now here, it's not about taking four variables. I'm just taking like two variables and A and B will be the two variables given in the question and they have been assigned an integer value. Like what they have been assigned, they have been assigned an integer value and you are supposed to get like firstly we have to be aware of the fact that when a question is given. Basically, the basically idea of the question is of that kind. Like A is given a value, suppose take 3. And for our convenience, I take the value B of as 4. If we convert the value 3 to 4, if we convert the value 3 to 4, the number of bits that need to be converted, we have to count. We don't have to name the bits, we have to count. Now, when the word is used here, bits, so we have to get the idea straight away that what we are supposed to be what we are supposed to be required. So we are required here with the bit manipulation concept. And what manipulation concept we require here is that we have to count the bits when we flip the number. This is basically in general language, it means that when we convert, like there are two numbers given in the question, the question itself has got two numbers, and we have to just count the number of set bits or the number of set bits, or you can call bits, whatever you call it, that need to be converted in order to get this number. We have to count it. So basically what we do, I will give you an idea how we count the bits. So to be just, I stand corrected. When we do this, I'm telling you, here in this question, I am just like to clear it as it might create doubt in you. So we are not concerned with the normal, like every bit. Okay. We are not concerned with the every bit in the number. We are simply concerned with the number of set bits that need to be flipped. What we are concerned? The number of set bits that need to be flipped. So how we do it basically? So moving forward, I would like to tell you how we do it. So like counting the number of set bits, I'm telling you, like if we use this term, suppose B has been initialized some value, take it, okay, I'm taking a big value, take it 30. So if B has been assigned a value 30, and if we do this operation, B and, now this and is not the logical and, we all know it, it is quite visible here. This and is not the logical and, this and is the bitwise and. This is what? Bitwise and. So this and is basically bitwise and. And when we do this thing, B minus 1, and when we limit this whole process, when we basically limit this whole process, we limit to what? We have to assign a condition till the time, because we are actually taking bitwise and. Bitwise and is a binary operator which requires two operands. Now, when it requires two operands, we have to basically do here, like we have to take two operands and like here b minus 1. So we are actually coming on the, like we are coming on the descending way. So when we are coming on descending way, we have to simply take it like while performing this operation, the value of b should not be equal to 0. Or in other terms, you can take it, the value of b should always be greater than 0. And we have to using a count variable, we can simply count the number of bits that are required to be flipped. So now I'm going to tell you the methodology or like the procedure of the particular way in which we will be writing the code. So firstly, we'll be taking the two values that are already given in the question. Like if the question is coming for random values, then we will simply actually take one variable a and the other variable b. Now, using a third variable like b1, we can call it. We will simply take what? We will take the XOR of this. What we will take? The XOR of this. Now, I think that everyone will be aware of XOR. Anyways, I'm telling you what is actually XOR. So XOR is basically if we do here A XOR B, and XOR gives you the output what? Now, XOR is basically, you can remember any kind of thing, but in my concept, what I remember XOR is like if you take here A, comma B, and if we write R represents here this operation, the XOR operation. So if I write here 0, 0, I go in the bit format only always, 0, 1, then comes 1, 0, and finally we end up doing 1, 1. So here, if I go with the XOR operation, so like I tell you the property of XOR operation in my own terms, what I actually always use it like that. If the number of ones, or if the number of ones in the two input, out of the two inputs initially, if the number of ones are odd, then this XOR operation gives you the value 1. And if this value is even, then this comes 0. So like that, if I tell you, and if I go about like a lot of people will be watching. So in like times of high and low, like if your if any of the two outputs, like is your one is high, then XOR gives you the value. And if any of the two values is like both are of like same kind, then XOR gives you the value 0. Because eventually what you're concerned with, when one of the two is different, then one will be always one. So one of the two inputs is now odd. So again, we will be going like this. 0, 0, XOR will give you always 0. 0, 1, XOR gives you 1. 1, 0, XOR gives you 1. And 1, 1, it is in total like the number of signals here, the number of ones here are 2, which is even. So in even case, XOR always gives you 0. So this is the property of XOR. I think you must be knowing it anyways. So like moving forward, what we'll be doing it. So here basically we had discussed till the time that we will be declaring two variables based upon the question. Then we will be taking the XOR. Now coming to that, what I told you initially here in this part, like we will be limiting this value. So we will be using our while loop. We will be simply writing here while, and then we will be applying the condition like b1 what had the value of the XOR of the two input variables, while XOR is greater than 0, or you can use it not equal to 0, both are correct. Then we will simply doing the operation what? B1 is equal to B1 and B1 minus 1. We will be doing here. So like we will be doing here, and then we will simply, while doing this, we will be also counting, incrementing the value of the variable count by 1 every time. And then we'll simply close it, and finally we'll return the loop. So I will show you this implementation with the help of the code as well. So like coming here, I have got you the code. Like this is the code for the number of, this is the code basically. So I'm telling you how do I write, how I have written this code basically. So like this, you must be knowing the header file that we preferably use. So we don't need to include each and every header file like vector for any kind of math operation and everything. Then we will come to, I have declared a class here. Now, as I told you in my previous video as well, or the videos that I will be uploading, that I take the format of class because we must be, or you must be performing the questions on various coding platforms where actually it is given in form of class. So we don't change it basically any kind of, we just simply write a main. And when we simply write the main here, we actually just try to just take the values that we have already taken as parameters in the function, and we simply calling through an object the particular class, and we simply print it. So here I have created a class named solution, and then because I have to call it, so that the members inside this class must be public, and then simply I have called, or I've created a function named find total bits. And then what I have done, I'm telling you here. So like as I told you, I have taken the XOR of the two input variables, and initially I have declared the variable count as 0. Now what this count will do, this count will simply do its functioning which it's when till the process the b1, the value of b1 which takes the XOR of the two values is not 0, it will simply take the value and it will increment it by 1. And since we have to count the number of bits that need to be flipped, so the thing that is supposed to be returned is the value count. Now, this your class part is over now. Now, what we will be doing it here is that simply we will be creating a main, and in main I have just to actually just statically I have given two values, and then I've created a object of the class solution. And then since we are returning a value of integers type, so when we are calling it in main method, we should supposedly call with the same data type. So I've taken a variable intc. I have called the function through an object. I have passed the two values which are taken as input, that is 10, a equal to 10 and b equal to 20. And finally, I have taken the value. Finally, I have printed it using the statement, the total number of bits required. So like now, how does this actually function? Now, there might be a confusion when you run it that how did it actually happen? So the procedure that XOR operates, XOR never operates on the integer values. Whenever XOR operates, XOR actually takes this value, supposedly binary. Now, binary is that this 10 will be converted to its binary term, this 20 will be converted to its binary term, and then XOR operation will take place using the concept that I told you. And then the C value will be storing this, the value of count. Now, how did this exactly take place? Now, when we are supposedly flipped, now when we need to convert the value 10, 20, how many bits of the number 10 are need to be changed to convert it to 20? This program will give you the output. So we were supposed to just count it. So I will be running this, and we will be getting it here. So the total number of bits required 4. So what does output mean? Like the total number of bits required 4. Now we were supposed to count the total number of bits that was supposed to be flipped when we convert one value into another value that is given. So the total number of bits required 4 here explains is that when we are given one value 10 and the other value 20. So when we will be converting the value 10 to 20 in bits format, the number of bits that are required to be changed are 4. So this was the question, this was our task, and hoping that it's clear. So thanks for watching. Do like it, share, and subscribe. Thanks for watching.